Hi guys, thanks for watching again. In this series I mainly wanted to focus on the basics of Arduinos and how to program them just like C++. So if you don't have a grasp of coding, you can still follow along with my videos or with anybody else's videos and you actually know what they're talking about. So if you have lots of coding experience or at least even a little bit, this might be not the video for you, but if you don't, please stick around and I hope you learn a thing or two. Once again, everything is up on my website as well in a written form, so don't be afraid that you have to keep watching the video again. If you want, you can just afterwards go to my website, read everything in your own pace and see if you learned something. Just as well, if you have any questions, please let me know. And let's just get started and see where we end. Today is going to be about data types. I'm going to split it all up into bite-sized portions, so it isn't going to be a video of 2 hours. So today it's going to be data types, next it's going to be arrays, after that it's going to be functions and classes. So let's dive. To understand what data types are, we of course first have to see what a data type is exactly, because I can't explain to you what data types there are if we don't know what a data type is. Well, if you and I would have a conversation, we talk in words and sentences, and sometimes we throw in letters or numbers. So let's say I am 4 years old, I threw in a number in my sentence. Well, if I would communicate on a level with you that said, hi, I'm Dave, tomorrow is my birthday. It is true, by the way. So tomorrow is my birthday and I'm 7 years old. This sentence was constructed of letters and words and I threw in 2 numbers. And you perhaps would say, okay, Dave, why are you talking so strange? Why are you declaring that you included some letters and some numbers? You would think I was going crazy, right? Well, in coding and in our computer, we actually need all that information. So we need to send the information. So in our case, our sentence. So I'm 4 years old? Doesn't matter. But tomorrow is my birthday, etc. And then we need to tell the computer, okay, what I just told you is a sentence. So that last part, saying this is a sentence, is the data type. So it has a value. Tomorrow is my birthday, and the type is a sentence, right? So in C++, we have the same. We have different kinds of data types. We have integers, we have chars, we have strings, we have doubles, and we have floats. And now you might think, okay, but what are you telling me right now? I'm just telling you that these exist. I will go into them in detail in this video, so don't worry if you're already lost. These things are just ways to tell what kind of data we are storing in a variable. A variable is, let's say, int is 1. So the variable, let's give it a name, int a. So the variable has a name, int a. It has a value. We gave it the value 1. And we declared that it is of the type int. See where I'm going with this? And this is how we communicate with our computer. We create variables, we assign values, and we tell the computer what kind of value is accepted in this variable. So, are we still following along? Let's just go by them one by one so we get a clear view of what is happening. So one of the data types I've mentioned is a char. A char is short for character, at least I think so. It makes it more logical in my mind's opinion. And in a char, we store a single character. And that could be an A. A char could be a B. But a char could also be a 2. If we define a char, we use single quotes And I forgot to give them all a name because they need to have a name. So we're going to say char A, char B, I'm going to say char C. So now we have 3 chars named A to C with the values A, B, and 2. Now if I would make another char, D, I would give it the value 3. We now have 2 letters and 2 numbers. So if I would do char, we're going to print it. So we're going to do serial.print. Let's say char C plus char D, right? Now what do you think would happen? Because in our communication, we would say 2 plus 3, like normal human communication, we would say it's 5, right? Well, in this case, it's a little bit different because we tell the computer 2 is text and 3 is text. So if we add those, we get 2 plus 3 is 2, 3. See where I'm going? Because we didn't define this as a calculate number we can work with, like we can do calculations with, divide, etc. A computer knows, okay, it's text, so I need to just append the first text with the second. Now a character is always one character. So it can't be A, B, C, whatever. So you might see it already tells me something is wrong here. I expect 1 and you're giving me 3. So that's not possible with a character. So a first data type is a character. It stores 1 value. And if we add them, it would just append the value of all these things. Now, if you would want to type hello, let's say char H is H, char E is E. And can you already see what is happening here? It's going to be such a drag. So char L is L. I'm just going to copy this one because it's taking me so long. And I'm going to do the same. Char O is O. So now I've written hello in chars and I could print it just like we did up here. So let's do char H plus char E. So I'm just going to copy. I hope you're still awake because I am not if I keep going like this. Char O. And the result will be hello. But this, you could try this, and there are probably use cases where this would be desired. I don't know which one yet, but they exist. I want to bet, but we have something other for that. So one thing we have is a char array. The char array, and next week I'm going to go into full details what an array is. But for now, I'm just going to explain it. An array is a little collection of, in this case, characters. So we could do char and then the square brackets is, let's say, hello. I need to use double quotes. So if we have one character, we have a single quote. If we have a char array, we use double quotes. So we're going to say char array A, it rhymes, is hello. And if we would print it, char array A, we would get hello. So just the same as up here, except we only declare it once instead of 5 times, and we only have to use the value name instead of all the individual characters. So this is just a faster way to create sentences or longer words. We could also do hello, my name is Dave, and it would print hello, my name is Dave. So that's how a char array works. Now, if we end a sentence in C++, we always end it with the dot comma. And if we have to recap what we've already done up until now, we have a character, which is a single character, which always a value always needs to have a name. So character char h in this case, and we assigned it a value. We could also do char h. So we've ended the line, so nothing is coming. So we know that char h is a value that can be assigned, but it hasn't been declared yet. Defined, sorry. So we said that if we want to assign something to this, it needs to be a character. So what we can do now is say, okay, char h is g. H. Apparently I hit the H. So now up here we said char h is going to be existing with, we ended the line. And down here we said, okay, now I want to assign it a value. So that's also possible. But in this case, if we want to assign a value, we already declared that is a character up here. So we don't need to retype this, because then a program would think you try to create a new character h, but you already have one up here, so something is wrong. So we can just remove this and use the name to assign a value. Okay. Now, next up is a string. Now you might think, okay, Dave, you had a char array, and that is possible to use sentences and words, etc. And you're completely right. In basic C++, a string is also something you need to add as an extra functionality to your code. You can't just use it out of the box. Arduino is kind of special in that. When you look at C++, and other languages, strings are used as the main thing for sentences and words. So we use the char array in C++, but if you go look at Java, Kotlin, C#, whatever, a string is something that you're going to see everywhere. And that's also what I've been using, and I think that's mainly because I come from another background in programming. So I just adapted this approach. So if you want to be the most efficient, you're going to go with a char array. And if you want to be like me and lazy, you're going to go with a string. So let's say string text is, and once again, here we can also use the double quotes. Hello, my name is Dave. And in the backend, it's actually just going to convert this to a char array. So in the end, there's not really that much of a difference. And this would also just type, hello, my name is Dave. So these two can be used both. They both have some different approaches how we can manipulate the data in it. But that is something for later on. So I'm just not going to go too deep into that right now. So, and also in a string or char array for that matter, if you would say string numbers is 1, 2, 3, and string numbers 2 is 1, 2, 3. Now remember, just like the chars, if we would print this, so let's say serial print numbers plus numbers 2, the result would be 1, 2, 3, 1, 2, 3. Once again, we said this is a text, so it's just going to copy the text over literally, and it's not going to interpret this as a number. We could convert this on a later point, etc. But as a plain string, we can't add these two values with like we do in math. So that's something to keep in mind. Now, if you would like to add numbers in math, we also have something for that, which is going to be the int. And floats and double floats. Now what's an int? An int, let's say int a, is a value that has no decimal points. So 1, 2, 3, 4, 5. And up until a very big number. It has a max though, but you're probably not going to reach it anytime soon. So if we're going to say int a, we could say int a is 4. We could say int b is 7. We could even int c is 7.4. But as you might remember, if you would print this, it would become 7 because it would emit the dot 4 because we can't work with decimal numbers in an int. So it's best to do it like this. With an int, we could int d is int a plus int b. Now what we said is that int d, so we created a new int, see a, b, c, no, we created a new one, d, has the value of a plus the value of b. So that's going to be 11, right? We could also do the same with strings. We can just declare a string by saying string numbers 3 is numbers plus numbers 2. So now in the declaration of what the value of a string is, we're already calling the other variables, so in this case int a and int b, add them, because we said plus, and remember ints can be added, subtracted, divided, like all the mathematical actions can be done in this one. So this would become 11. Now if we would int e is 7 divided by, let's see, 2, it would become 3.5, but it will round it to 3. So that's something to keep in mind, no decimals, and we can use mathematical operations on it. Now you might think, but I sometimes use decimals in my plans, and that's quite obvious, because who doesn't? I'm going to introduce a float. And the float is a decimal, a digit that is precise up to 7 points after the decimal. So let's say float a is 1.4578, I don't know, whatever. So this is a valid float. You could even, and now you might think, okay, but what have you just been telling me? 2. This is also a valid float. But now you might think, okay, but why don't we store this as an int? Well, you could. That's quite obvious. So why don't we use all floats instead of ints? That's maybe a better question. Well, in that case, I would say performance. Because, and this is mainly something that has been a deal before the computers we are using right now, because the floating point operations, so a number with a decimal, or at least one that could store a decimal, would take up more speed than an int would. Their size is the same, but the operations executed on them is going to take longer. Now, if you have a very simple program, you aren't going to notice any difference. And even if it's going to get a little bit bigger, you could get away by only using floats. But I would suggest that if you know that you're not going to use any decimal, just use an int, just to learn some good practices. And there are some cases where you would like to really define that you don't want a decimal. Because let's say, for an instance, you're at a party, right? And you have a magic trick lined up with 10 doors. And you ask one of your friends to give you the number between 1 and 10, and you open a door and there's something magical behind it, right? Unicorn, bunny, pigeon, I don't know. So if you ask that friend to give you a number, you could get two types of friends. One, the friend that's going to say 4, and you love him, right? You're going to open door 4, you found the pigeon, everybody's laughing, big surprise. Now, the other friend, on the other hand, he is more of the special type, He's going to say, I want my favorite number is 1.74890. Now, you might think to yourself, darn it, I should have brought 1000 doors to include all the edge cases if somebody said a decimal number, right? But if we just would have declared, I want a number between 1 and 10, that's going to be a whole number, so an int in this case, you would avoid that one special friend to give you the 1.7450, and you could have just finished your magic trick without any sad faces or any hurt feelings. So that is why sometimes you just need an int. So you can force your program, or perhaps even the user input, to be something you can work with a whole number, instead having to find something to convert a float to an int to emit the decimal values in the first place. So you would just have extra work while an int would just suffice. Now the same can be done here. You can add them, subtract them, divide them, multiply them without any issues. So that is something to just, you can just work with. Now float, let's say float C, and even here, like in all variables, we could do float A plus float B. It's going to be, and this is going to be 3.458795. So we can just add with this, even though it doesn't have a decimal in place right here, we can still add it as a float. Now, like I said, floats are precise up to 7 decimals after the dot. But what if you have something that's going to be so critical to be precise? Let's say a stock market, I don't know, even though stock markets have more advanced ways to work with the numbers because they're going to have to be really precise. But let's say just you're going to do something with stocks that's okay if it's precise, it doesn't have to be scientifically sound, etc. We're going to use a double. So double A is 1.458795. A double can be precise up to, I'm quickly going to look over that. I'm not going to lie to you. A float was precise up to 7 digits after the dot, while the double is precise up to 15 digits after the dot. Now I said that a float takes as much space as an int, but works longer, or takes longer to process. A double actually takes, you might have guessed, double the space of a float. So this is something where space does become an issue, because you would increase your variable by twice the size, while perhaps you don't even need this much precision in the first place. So let's say double A, double B, double B is 2. Because you can imagine that when you were a child and you were selling candy bars, and somebody gave you $1.50 or €1.50, and you have to give him change because it only cost $1.20. There is no need to be precise up to 15 digits after the dot, right? Nobody is gonna look at the fluctuating prices of the euro or the dollar compared to the inflation with the candy bar you're selling. It's just a simple transaction. 1.50 minus 130 is 20 cents. You don't need to double the space, double the processing needed to actually handle doubles. So if you don't need them, I would suggest just stick to a float if you need a decimal. If you don't need a decimal number, stick to the int. So that's something to keep in mind. You could always use a double and you have all cases covered. But this would be bad practice because things would get unneedingly big and you would get values that are unneedingly big. you're gonna get rounding done right, but you need to interpret this how you're gonna, because this is gonna be 1.46 in money wise, 1.45, right? So why do we need all these things in the end? So that's something to keep in mind. If you're gonna program, you're gonna use variables, you gotta think, what is it I need? And why do I need it? Do I need a double? Some cases, yes you do. Do I need it in simple mathematical solutions? Probably not. Do I need it when I try to count till 10? No, you don't even need a float, you can use an int. Do I want to display text? Okay, go for a string or a char array. Do I want to print only an A? Just go with a char. If you follow that guidance on that line, you're gonna be just fine. Now there is one data type that is still left, and it's the Boolean. Now, a Boolean is a statement. A statement that can be two things, true or false. So let's say bool A is true. This is already a valid Boolean. We could even do something like this. Bool B is 2 is equal to 3. Now, obviously, this is not true. So bool B would be false. Boolean bool C, balls, okay, bool C is false. So we can't add them, we can't subtract them, because we can't do true, or true minus false is, I don't know, false or true, whatever. We could do, like already do statements. So if 3 minus 4, let's do it in brackets, 3 minus 4 is equal to 1. So this is going to be true. So we can do quite the logical operations on it. And this can be used because sometimes we just need to know that, and we're going to talk about this in one of the next videos, but I'm just going to give you a little sneak peek. If, let's say, bool A, do something. So if bool A is true, do something. We could also do if bool A is false, do this. So we could create some logic that, let's say a value comes in. If it's higher than 5, bool A is going to be true. If it's going to be lower than 5, it's going to be false. Or we could just say incoming variable is bigger than 5. Because this is also going to return true or false, right? Something is coming in and it's going to be bigger than 5 or lower than 5. So these are actually just the basic data types that we need to know when we start programming in Arduino. There are some more complex ones, some more advanced engineered data types, but these are just the basics. And in my opinion, you can almost do anything with these. So I just want to close it by saying, take your time going through this stuff, because in the beginning it can be quite a lot. But once you get the grasp of it, it's going to be, at least this part, is quite logical and simple once it clicked. Before it can still be all bit gibberish, so take your time, don't feel rushed. If you have any questions, please let me know in the comments. Next week, I've already said it a little bit as a teaser, the Char Array is a collection of characters, but we also can create collections of other things. So we're going to go over that and how we can work with them, how we can access the data in those collections, and how we can change the data. I hope you've learned something, and leave a like and subscribe, and I'll see you next time.